We begin by importing the necessary modules from Three.js. Here, we have the Base3 object and the orbit controls from the Three.js examples, which allow us to add interactive control over the camera view in our scene. Next, we create a new scene object. This will be the container for all our 3D objects and will act as the virtual space where we render our graph. We then set up our camera with a perspective view. The first parameter is the field of view, the second is the aspect ratio based on the window dimensions, and the last two parameters define the near and far clipping planes. Here, we initialize our WebGL renderer, which will create the canvas element where our scene will be drawn. We also size it to fill the entire window and attach it to the document body. With orbit controls, we link our camera to the canvas, allowing users to rotate, pan, and zoom within the scene using their mouse. Our dataset is an array of objects, where each object represents a point in our 3D space with X, Y, and Z coordinates, along with a value which will determine the height of each bar in our graph. We create a single geometry that will be used for all bars. This is a box geometry which shapes our bars like cubes. The parameters provide the width, height, and depth of the bars. The material for our bars is a mesh basic material, given a green color. We've also made it semi-transparent to give it a glass-like appearance. The opacity is set to 0.75. Here's a function to create individual bars from the data points. For each data point, we create a mesh using the geometry and material we just defined. We set its position based on the X and Z values from the data, and initially set the Y scale to 0 to prepare for the animation. Finally, we add the bar to our scene. Using Map, we transform each data point into a 3D bar by calling our createBar function. We now have a collection of bar meshes ready for animation. We position our camera away from the origin along the Z-axis to ensure all bars can be viewed when the scene first loads. The animate function serves two purposes. It creates a loop that allows us to animate our bars growing upward, and it updates the renderer at each frame. We grow each bar incrementally until it reaches the value specified in our dataset, adjusting its position so it grows from the base. We call this function to start the animation loop. Finally, we add an event listener to handle window resize events. This ensures that our camera's aspect ratio and the renderer size are updated appropriately, keeping the visual proportions of our graph correct.